Hi, welcome back to our new video. And today we will continue our SolidWorks series. And now in this lecture we will discuss swept boss base, swept cut, and we will also look on fillet. And we will design this part here, and in this part we will use fillet on these edges. So let's start the sweep boss base. For this swept boss base, we have to make some sketch, and on this sketch swept boss base can be used to make the solid body around it. We can use the default circular template which is exist in the swept boss base, and we can use some any profile. So let's take let's create S. You will using supplying. I will be pointing first from the origin 1 point, like this, like this, like this, and this. Now we have the S. Yeah, yes, now that's look like more like S, I guess. Yes, that's perfectly okay now. Yes, now I guess it's more. Okay, so simply I have created this. Now if I go to the swept and click on circular profile, that is a default, and selecting on this, I can change the diameter to 30. Let's select on click. 30 means the diameter here is 30 now. Okay, but if I don't want this to be a circular, then I must create a profile sum, and profile must be created close to this, and it is better that the profile must be touching the sketch we have designed in a new sketch. So let's say I click right plane, and on this I just do rectangle. Let me take this and this. Okay, now it's a rectangle which is touching the origin, which is touching this sketch. So clicking on swept on the default sketch profile, and the sketch profile we can show the default demonstration here, that we have to select the profile and then select the line. So for the profile I will select this, and for the curve I will select this. So this is by clicking on OK, we have our S. Okay, so let's create some other profile. Now this time not rectangle, oh sorry, triangle. I will create some, let's say, slot. Let's swept, clicking on this and clicking on this. Now we have again S here. Okay, so now this has been designed. Now the one other thing we can do here is, by clicking on this, we can use the guided curve, but it is used in complex geometry. We can use this chart and tangency, and it is also used in complex geometry. And thin feature tool. Thin feature tool means by clicking on circular profile and clicking on this, we have a solid circle going through the, but we don't want to solid circle to going through. In pipes, when we use swept in a pipe cases, we must know that the pipes are hollow inside. To make the pipes hollow inside, we use thin features. Thin feature means how much thickness we want of the pipe. So currently it is defaulted to 1 mm. By reversing the direction, we can see that 10 mm will be the outside diameter then, and 1 mm will be the inside. So 10 minus 1 means 9 diameter. 9 mm will be the inside diameter. By clicking on outside, now the outside diameter will become the new diameter, and inside diameter will become the original diameter, it is 10. Same here, we have option of mid plane and two direction. Two direction means going downward, going upward too. So let's say we select mid plane and click on OK. Now we have hollow S. So this is what a thin feature can do. So I am closing it. Now we will design this part here. So for designing this part here, I will select the right plane and will design from this. The overall length given is 120, overall width given is 100. The slot dimension given here is 60. The distance from slot to the edge is 30. Slot width is 15, radius means 30 diameter, and outside radius is 30. 2x means two sides, 1 and 2. Same here, 2x is given is, and then that means that there here and here as well the radius is 20, and inside radius of the slot is 6, length of slot is 80. Okay, so let's start by making the left side first. We can also design this from front side front side no we can also design it from top plane, and then we can extrude this, and then we can cut this, but we have to use the evolve. Then I will select front plane, and on the front plane let's design this rectangle of 50 into 100 L with a thickness of 20. So let me show you how the revolve feature work or extrude thin feature work. Given the dimensioning 50 and this one is 100 and the total thickness is 20. So extrude basing. Now clicking on again front plane, I will change the thin feature direction to inside. Now we want it to be 20. Now I don't have to close the L shape, it will automatically close the L. So this is what a thin feature can do. Let me select mid plane here. So 10 mm is forwarded, 10 mm is backward. So overall length required is 120. So I will select mid plane and I will click on 120. Now we have the rough structure of here is. Now we need to just do the slots and fillets. First let me do the slot. For the slot purpose I will just randomly create slot, and then I will do the dimensioning. Slot length given here is 60, like here, that is 60, and the radius is 15, and the distance from the left side is 70. Center to the edge is 70, and center and the edge distance is 30. So this is complete slot. And then this must be 30. No, this is 70. Then we must have no, okay, it's okay. Since we thin feature in the mid plane, the 10 mm has exceeded to the left side. We must kept in one direction, that is in that direction. So I will change my mistake, click on one direction. Now it will be perfect. Yes, now 70, now it will be 30, and just clicking on Extrude Cut and selecting through all. Now I will show you what other features can do here. We have through all both, up to next, up to vertex, up to surface, offset for surface, up to body. Up to body means this is the body, complete body. I will select and reverse the direction, and it will cut throughout, because this is a complete body. Cut extrude means it will cut up to the body. So this body ends here, so it will cut up to that. By clicking on click, we have a through all cut. So again, let me choose now through all. Through all means wherever the last solid body exists, it will cut till that. So since I can see that this is the last line, before that nothing is solid, so it will create till that. But if we do in reverse direction, the last surface body, solid body, is till here, so it will cut till that, but there is no solid body to cut in the sketch we have designed, so it will give error. That intended cut does not intersect the model. Please check the sketch interaction. Since the solid body is downward, not upwards, so it will not cut the, it is not able to cut the body. So changing the direction, we can again see that the cut slot has been made. So next is up to next. Up to next means the next surface body. So if we have a distance of 10 mm and then new solid body, then the new solid body wouldn't have been cut because of up to next. And since to the up to vertex mean the that point where we want the cut, finish of cut. So I have clicked this point. So the now the cut we can see that is still that, you can see. So up to surface means the surface to where we want the cut. You can see that I have clicked the surface. Now the intended cut can be shown here. So by clicking on tick, we have here the slot. So clicking slot here too, I will just do that. Click on this. I will use vertical. The length here is given is 80. Slot length is 80. Radius is 6. And the let me see the distance of this. The distance I guess is not given. So that means the fillet here is will be concentric. So let me first do the fillet here. Fillet means I will just click on the fillet here, and the fillet here is 20. So radius is 20. I will click here, give it 20, and I will show here is partial preview. Now we can see the fillet. Okay, now we have generated a fillet. I will drag this sketch downward. Again here I will make this concentric. No, it is cannot be. Sorry, this cannot be concentric. My mistake. Let me just cross that. Exiting. The dimension given here is given. That is 30. I missed that. That is 30. Now we have just two features. Extruded cut. Now we will just do through all because the slot is needed is through all. Now the fillet required here in the bottom also, that is of 30. I will just write 30 here and tap on the locations. Now we have exactly what we wanted. We can also use fillets on this sides, on this sides and bottom sides, like this. Like this is fillet. The fillet has been generated. So the fillet has been generated here. We can do the fillet here too. Now we have the fillet all over the place. Now if we want to do at the bottom, let me just do fillet here, and just like that the fillet is all over. You can see the smooth surfaces here because in the view tab and display tab I have removed the tangent line. That is why it is so smooth. By clicking on tangent line visible, the exact part is like this. So you can also change it to, for better visualization, you can change it to the tangent lines remove. So now let's start designing and learn how to make a swept cut. So same like we used a curve in swept boss. Let me first make a S again. Circular profile, clicking on it, 20 mm, and again if I click on that sketch and click on swept cut, but this time I will make it 10 not 20 mm. Oh, sorry, not 20, 18 mm. Now you can see the 18 mm hole has been created. There's a two ways of to do so. First I told you that we can do it by thin feature, and now we can also do it by first creating the sweep, and then using a scheme sketch we can use the cut sweep feature to make this so. So this was all today. So this was all, and thank you so much for watching the video. In the next video we will be discussing the other features.